Exponents. This is a review of Part 1. In today's lesson, students will review different forms of exponents. Repeat after me. Exponent form. Expanded form. And standard form. Very good. Today we're going to use this table to look at different forms of exponents. Now, when you look at a number that's in exponent form, who remembers what is the name of the big number? The big number is called it's called what? The base. And then we read this as 2. 2 is the base, right? And what is the power, or what is the exponent? The exponent is the little number, right? So I'm going to make this in red. What is the exponent in this problem? It's 3, okay? So because this is a power, we call this 2 to the power of 3. Repeat, 2 to the power of 3, or 2 cubed. Okay, so what is 2 cubed? Does it mean that you should do 2 times 3? Is that what it means? Because that's what a lot of you do. That is not what that means. It means that you're going to multiply the base, which is 2, by itself how many times? 3 times. So that means when you put it in expanded form, you're going to get 2 times 2 times 2. So you have 2 multiplied by itself 3 times. Does that make sense? That is not 6. When you're multiplying more than one number, you have to use a V. So you say, well, 2 times 2 is 4, but then you have to bring down the other 2. So what is 4 times 2? 4 times 2 is 8. Okay, so 2 cubed is 8. Now, when you use the table, I will give you one of the forms, and then you have to fill in all of the other boxes. So what about when we're looking at expanded form? And the expanded form is 3 times 3 times 3. Well, 3, is that the base or is it the exponent? What is it? What is it? It's the base. So you're working with the number 3, and I'm going to ask you a question. How many 3s do you see here being multiplied together? Okay? You have 3. You have 3 3s, yes? So because you have 3 of them, the exponent or the power is 3. So in exponent form, we write this as 3 to the power of what? 3. Very good. 3 to the power of 3. So what is 3 to the power of 3? Is it 9? Is it? Is it 3 times 3? No, that is not what it is. Okay, look, 3 times 3 is 9. Okay, but then you have to multiply it again by this 3. So what is 9 times 3? If you skip count by 9, 3 times, right? 9, 18, 27. Very good. Okay, now this one's a little trickier. I've told you that the base is 4. Write that down. The base is 4. But when you expand it by some power, you're going to get 64. So I want you to think about this. How many times would you multiply 4 by itself, right, to get 64? How many times would you multiply 4 by itself? Well, what happens when you have 2 4s that are being multiplied together? Let's take a look at that. When you have 2 4s being multiplied together, what is that? That is 16, right? Well, what happens when you have one more 4? Then you're going to multiply 16. I'll make this in red. You're going to multiply 16 times 4. Okay? Anybody remember what 16 times 4 is? I'll do it over here. You can see. Wait, I'll just do it over here. 16 times 4. Okay? 6 times 4 is 24. Carry the 2. 4 times 1 is 4, plus 2 is 64. So how many 4s do we have here? You have 3. Oh, they all have the power of 3. Okay, so you write it in exponent form as 4 to the power of what? To the power of 3. Very good. Go ahead and get that down. Okay, so these examples all have positive bases. In the next example, we'll do negative bases. Now go ahead and fill in your chart. We're going to be using negative bases. And if you remember, there is a rule with negative bases. When you have a negative base and the exponent is even, okay, let me see if I can write it here. When the exponent is even, the answer will be, or the value will be what? Positive. When the exponent is odd, the answer will be negative. So I'll ask you again. So what are even numbers? Even numbers for exponents are what? Count by 2s. They're 2, 4, 6, 8, 10. Odd numbers, let me do even numbers. 2, 4, 6, 8. Odd numbers are what? They are 1, 3, 5, and 7. So when you have an even number of negatives, your answer is positive. When you have an odd number of negatives, your answer is negative. Okay, so that's important to know. Let's take a look. Negative 6 to the power of 2. What is the base? The base is negative 6. What is the exponent? How many times are you multiplying negative 6 by itself? What's the exponent? The little number. The power is 2. We say 6 to the power of 2, negative 6 to the power of 2. Or, read this with me, negative 6 squared. What? Negative 6 squared. Good job. So if we expand it, it does not mean 6 times 2. And a lot of people are going to say, well, it's 12. No, it's not 12. Okay, it means negative 6 times what? Negative 6. So you're going to do negative 6 in parentheses with a dot for multiplication, negative 6. All right, negative 6 times negative 6. Negative times negative is what? Negative times negative is positive. Is 2 an even number? I'm going to ask you again because you weren't listening. Is 2 an even number? Is it? Yes. So what would the answer be? The answer has to be positive, right? Because negative times negative is positive. And negative 6 times negative 6 is positive 36. Very nice. Okay, so now we're going to take a look at expanded form, and you have 3 negative 3's. How many times is negative 3 being multiplied by itself? 3 times. What is the base? The base is negative 3. How many times is it being multiplied by itself? Count with me now. 1, 2, 3. Very good. 3 times. So in exponent form, we're really taking a look at negative 3. This has to be in parentheses. Negative 3 to the power of 3. Very good. Negative 3 to the power of 3. So let's work this out 2 numbers at a time. What is negative 3 times negative 3? Negative 3 times negative 3 is, oops, it's not negative. Negative times negative is positive 9. But then you're going to multiply it again by negative 3. Okay? So what is positive 9 times negative 3? It's negative what? Negative 27. Very good. So again, is 3 an odd or an even number? It's odd. So your answer was negative. Okay? Last example. This one's a hard one. Okay, you have negative 2 as a base. How many times do you multiply negative 2 by itself to get a positive 16? Well, I'll give you one hint. If the answer is positive, that means that the exponent has to be what? Has to be, what's this word? Even. So you're either choosing 2 or 4, okay? 2 or 4. You know that 2 times 2 is 4. So if you chose 4, okay, so I told you negative 2 times a negative 2 is 4. Is that right? Well, if we make it to the power of 4 or expand it 4 times, then we're working with 4 2's that we're multiplying. So 2 times 2 is 4. We'll do it again this set. Negative 2 times negative 2 is 4. And what is 4 times 4? Is it 16? Yes, it is. So how many times did you multiply negative 2 by itself? How many 2's do you see here? You see 4. So the exponent form is negative 2 in parentheses to the power of 4. Go ahead and get that down. Very good. Let's go ahead and take a look at another way to visually represent different forms of exponents. So this is a circle map. What do you use a circle map to do? You use it to define. To do what? To define. So in the center, we are defining exponent form. Okay? What does it look like? There's different forms of it, right? So if the base is 10 and the exponent is 2, then that means we're really talking about 10 to the power of 2. Now there is something very special about 10. And what you need to know is that whenever you have an exponent with the power of 10, you're going to put a 1 with this many zeros. You're going to do what? You're going to put a 1 with this many zeros. So 10 to the power of 2 is 1 with how many zeros? 2 zeros. And this is why. 10 to the power of 2 in expanded form means that you're really talking about 10 times 10. What is 10 times 10? Isn't it 100? Isn't 100 1 with 2 zeros? Isn't it? 1 with 2 zeros. So when you're working with powers of 10, and let's go ahead on the side, you're going to write this. You are. Okay. Let's just see, let's test your knowledge here. Okay. Let's look at some patterns. What about 10 to the power of 3? Shouldn't it be 1 with how many zeros? 3. 1, 2, 3. So it's 1,000. What about 10 to the power of 4? Shouldn't it be 1 with how many zeros? The exponent's 4. So it's 1, 2, 3, 4. This is 10,000. Repeat after me. 10,000. What about 10 to the power of 5? Well, that should be 1 with how many zeros, guys? Don't put a comma. With how many zeros? 5 zeros. 1, 2, 3, 4, 5. And you're going to go back every 3 zeros. 1, 2, 3, comma. That's 100,000. That's how much money Miss Cotrine makes teaching at Holland Crest. Just kidding. Okay, and then you have 10 to the power of 6, which is 1. Oops. With how many zeros, my friends? 1 with how many zeros? 6 zeros. That's right. So you're going to say 1, 2, 3, 4, 5, 6. You're going to go back every 3 zeros. You're going to say 1, 2, 3, comma, 1, 2, 3, comma. Does anyone know how much money this is? It's 1 million. Okay, is 1 with 6 zeros, $1 million. Wow, that's crazy. Let's do another example with a negative base. Okay, so here we have that our base is negative 9. Let's go ahead and write that in a parenthesis. And the standard form or the answer is 81. So how many times do you multiply negative 9 by itself to get 81? Okay, this one's pretty easy. How many times do you think? Who thinks it's 2? You're right. So it's 2 times, okay? So if I say, what is negative 9 times negative 9? Now, first of all, I'm going to ask you, is 2 an even number? Is it even? Yes. So the answer should be positive, right? What is negative 9 times negative 9? Is positive 81. Very good. So in the center, we have defined negative 9 in parentheses to the power of what? To the power of 2. Very good. Go ahead and get that down.